In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. So for example 1, you were given 4 problems to practice the concept of expected value. And essentially what you need to do is define what events are occurring, how that relates to a numerical quantity, and what the probability of that event occurring and either getting that quantity or not getting that quantity, whatever the case may be. So for instance, for this small conference, you have 195 people will attend if Dr. T-Bull is the guest speaker, and 80 people will attend if she is not the guest speaker. There is a 40% chance that the organizers will be able to get Dr. T-Bull as a guest speaker. Determine the expected number of people who will attend the conference. So, I'm going to set up this little table. It's only going to have a couple of items in it, but A is the event occurring, and this will be a numerical event in the long run, but it's going to be associated with, a descriptive event, and this is the probability of that occurring. So one instance is that Dr. T-Bull is going to be the guest speaker, which means 195 people will show up. But we're told that's a 40% chance of that happening, so the probability is 0.4, converted from the percentage. That means when I look at the number of people that can attend if she is not the guest speaker, if she's not the guest speaker, then I'm going to have 80 people show up. And since that's the only other option, I mean, either she's going to be the guest speaker or she's not. That's a 60% probability. They didn't come out and tell us that in the problem, but those are the only two outcomes. Either she's going to be the guest speaker or somebody else is. So these are my values, my actual members of my sample space. This is the probability each one of those is going to happen. So when I want to calculate the expected value, or in this case the expected number of people that will show up, I'm going to take 195 times that 0.04, that 0.4, and I'm going to take 80 times 0.6, and I'm going to add them together, which becomes 78 plus 48, which is 126. So on average, we expect 126 people to show up to this conference at this time, not knowing whether or not we've secured Dr. T-Bull or not yet. Bobby's an investment counselor, and she's advising her client on a particular investment. She estimates that if a tax law does not change, the client will make $15,000. But if the tax law changes, the client will lose $4,000. Determine the client's expected value if there is a 20% chance the tax law will change. So again, I'm going to be looking at a table very similar. Again, this event happening is going to be a number, but it may have some sort of descriptive event that occurs because of it. And basically it's going to be based off of the tax law changing or not. If the tax law does not change, she's going to make $15,000. And since there's a 20% chance that it will change, that means there's an 80% chance that it won't. And 80% written as a fraction or as a decimal is just 0.8. If the tax law does change, she's going to lose $4,000 since this has to be negative, and that's a 20% chance, which is 0.2 in probability. And so I'm going to do the estimated investment earnings or the expected value the same way I did the previous one. I'm going to take the $15,000 times 0.8 plus negative $4,000 times 0.2, which gives me $12,000 minus $800, which is about $11,200. So basically, on average, Bobby's client will make $11,200 on this investment. For this next one, you're given this spinner, and you're assuming that the person spins the pointer is awarded the amount indicated on the pointer points. If it's a positive number, it must pay the amount indicated if it lands on the negative number. So they want you to determine the person's expectation if the person plays the game. And so you have a couple of choices here. Basically, when you look at this, there's 3 outcomes I can have. The outcomes are that this person's going to lose $10, they're going to get $2, or they're going to get $20. These happenings do not all have an equal chance. If I just left it at this and just said, okay, if I just average these three numbers together and get a value for that, that would be me assuming that they all have the same possibility of happening. They don't, because the $10, the losing $10 spot takes up half the wheel, whereas these two together take up half the wheel. So basically, when I look at these areas of this spinner, half the spinner would have you losing $10. A quarter of it will have you getting $2, and a quarter of it will have you getting $20. So the probabilities of each one of these occurrences are 1/2, 1/4, and 1/4 respectively. So to find the expected or the expectation of this, how much we're going to win or possibly lose, because you know some of the choices down here, they lose 50 cents, they lose $4, they win $4, or they win 50 cents. I got to find out which one of these it is. So the expectation, I'm going to do -10 times a half, plus 2 times a fourth, plus 20 times a fourth, which gives me -5 plus 0.5 plus 5, which ends up being 0.5, or in this case, since it's dealing with money, it's 50 cents. Since this is positive, that means that the expectation is that this person spinning the spinner is going to gain 50 cents on average, and that's what this choice down here is. So, on average, a person playing this game is going to get 50 cents each time they play the game. In another game, a person randomly selects one of the 4 envelopes shown below, or actually above in this case. Each envelope contains a check that the person gets to keep. However, before the person can select an envelope, he or she must pay $15 to play. Determine the person's expectation if the checks in the envelopes are for $2, $2, $100, and $4 respectively. Now, I don't know which color envelopes are in. It would be a random choice. But there's 3 outcomes with this. I have to keep in mind that I am paying $15 to play. So if I pay $15 and get a check for $2, I did lose money. If I get $100 or $400, that means I've gained money. So I got to consider these when I look at these. So my outcomes, if I do this table, is I pick a $2 check. That means I'm going to overall lose $13. And there's 2 envelopes that have that. So 2 out of the 4, or 1/2. So I have a probability of 1 out of 2, or 50%, whichever way you look at it, of me losing $13. If I pick the $100 check, that means I'm going to gain $85 because I'm still spending that $15 initially. I have a 1/4 chance, or 1/4 probability of that. And the same thing for picking the $400 check. My overall winnings would be $385, and that's a 1/4 chance of that happening too. So my expected winnings would be -13 times a half, plus 85 times 1/4, plus 385 times 1/4, which gives me $111. Which means this will not be a good game for someone if they were trying to use a game to, collect funds for charity or something like that. That means that the person playing the game, on average, will win $111 each time they play this game. So, not really. I mean, it's expensive to play, but on average, a person can expect to win $111. Winning a door prize. Suppose Josh attends a charity event and is given the opportunity to purchase a ticket for the $50 door prize. The cost of the ticket is $2, and 100 tickets will be sold. Determine Josh's expectation if he purchases 1 ticket only. Well, if he purchases 1 ticket, he can either win, which is a 1 out of 100 chance. He only has 1 ticket out of 100, and he's going to gain $48 because that's what the door prize is, but he spent 2 already. Whereas Josh loses, he's going to lose that $2, and there's a 99 out of 100 chance of that happening. So the expectation here equals 48 times 1 over 100 plus negative 2 times 99 over 100, which means that's a negative $1.50. So on average, if Josh buys one ticket, he will lose $1.50. And we expect that to happen because it should favor the house. I mean, whatever group or organization are selling the tickets, because they're trying to make money. Fair price. At a game of chance, the expected value is found to be a negative $2.50. The cost to play the game is $6.50. Determine the fair price to play the game. Your textbook kind of really simplifies, how to find the fair price, because essentially they're saying, okay, find your expected value, whatever it would be. Okay, what's the probability of you, whatever the case may be. So the expected value is negative $2.50. The cost to play the game is $6.50. So the fair price is just the expected value plus the cost to play. So in our instance here, it's going to be negative $2.50 plus $6.50, which gives you $4. There's more complicated ways of calculating it, and actually that are more realistic, because usually someone's going to determine what the fair price is, and if you're running the game, you're going to make sure it's not a fair price, because you don't want the person breaking even on average, or even the person winning on average. You want the person losing on average, because that's how you're going to make your money. So it's more complicated than what they often, the way they're portraying it. But fair price is something that isn't really a main focus of the course. It's just you do have some examples that do ask about it, so that's why I chose to cover it. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.